Um, I'm Mark Rickert. I work here at Skookum Digital Works. I've been here about 4 years. I am a senior developer here, which means basically we get to oversee a lot of the architecture of the applications from start to finish, and we also work with making team decisions about where the project's going to go, in what direction, and that sort of stuff. I like hacking on hardware and software, and I like to tinker with things. So I put this talk together a couple months ago just so that I could present to a local technology executives meeting, and so I figured I'd share it with you guys here today. So whenever we talk about the future and the internet and how the internet's going to affect our lives, if you do an internet search for the internet, you find stuff like this, and it's people have this this crazy idea of what the internet. Can we turn this down a little bit? I'm getting some feedback. So we have this crazy idea of what the general public thinks of the internet and how you get on the internet and what it all means. And it's there's thousands of images like this out there on Google image search or Bing or whatever your poison is. But really, when we're talking about the Internet of Things, it's not so much this crazy cyber war futuristic stuff. It's stuff that we have today. We just need to figure out how to put it all together and make it work right. But let's start off here with a definition. The Internet of Things, the working definition that I'm going to be using for this talk is physical objects seamlessly integrated into the information network, and where physical objects can become active participants in your daily life and business processes. So essentially all that means is that we're taking these devices that they all talk to each other, and they're not just dumb nodes that just collect data. They're actually doing things. They're making decisions for you, and they're helping you make more informed decisions. So it's like some Matrix shit. It's ooh. It's we're all in the Matrix now. But at the core of the Internet of Things are devices. Devices can be anything like your cell phone that you carry every day. Your computer is a device. But what a lot of people don't think about when I talk about devices is this can be a device, right? It does data collection. It has readouts. All we have to do is figure out a way to make it actually do something useful other than just tell the power company how much power we've used in the last month. That may or may not be accurate, because we don't know. It's a little black box. But there are strides being made in actual technology for these power meters, where now they have digital power meters. They've got, which oddly enough take up power to use. And my brother-in-law actually has a power meter on his house that he discovered that it has a little infrared light on it. And every 1/10 of a kilowatt hour, it pulses a flash of infrared light. And so he was actually able to take that and build a little thing out of an Arduino. He got an infrared receiver, and now he graphs his power usage over time online. This is a device. You know how many sensors are in that car? Thousands. There's all sorts of crash sensors, speed sensors, pressure sensors on the brakes and the accelerometer and things, or accelerator and things like that. Sorry, accelerometer. So this is just a whole host of devices that are already interconnected. They've got a centralized computer. We just don't really have any way to talk to that computer to actually get the information out of it. Actually went to a really interesting talk at DEF CON this past year in Las Vegas about pulling crash data out of the black box in computers, and how these guys had figured out how to actually read that data and analyze it, because up until now it's just been a function that the car companies could go and they could look at that and then provide that to the government if they needed it and whatnot. And now recently on the market, there's been a lot of these wearable consumer devices that have come out onto the market. Things like Fitbits and Pebble watches and the Fuel bands. Another interesting one is the digital insulin pump that you can you can basically dial it up and down. My a cousin by marriage had one of these. He was letting me look at it one time, and he just has a button where he actually still has to prick his finger, get his insulin reading, and then change his insulin pump. But what if that insulin pump could actually automatically read your blood and then change it? It's already got a line into your system anyways to feed you the insulin. So it's not too far removed to have that actually happen, where it's making the decisions for you, so you don't even have to think about your insulin pump throughout the day. And then there's like things like wearable heart rate monitors and things like that. But here's another one that you might not think of as a device. Right? It has sensors. It's a lot of lawn systems have rain sensors, so that it knows not to, sometimes knows not to water your lawn. But that's one thing that really bothers me, is like when it's raining out and I'm walking down the street and I see like a building that has the sprinklers on. It's like we're too technologically advanced in this day and age to still be watering the lawn while it's raining out. I mean, there's no reason to do that at this point in time. But all these devices have all these sensors that are talking to each other, they're communicating, and they're gathering data. And so that's the really important part. So we've got these devices that we use in our daily lives, and they've all got these sensors. And there's a lot of different types of sensors: humidity, motion, light, vibration, and they're all really, really, wow, I don't know why that went automatically, but yeah. Electric current, GPS, EMF. You can detect electromagnetic fields, which is pretty cool. Tilt sensors, you can tell what angle things are at. Air composition, we can determine carbon monoxide levels. That's been in smoke detectors for years. And all these sensors, they're just really small things that they're hardware devices that read things about the world around us, and they're all very specialized, and they all talk together. Another internet picture. They all talk together to form this web of information that may or may not be accessible to us. What the Internet of Things is about is really just making that information accessible so that we can make decisions based on it. And whether that decision is made on the device, or if it's made somewhere else out in the cloud, or at your home machine that decides what you want to do with it, that's the ultimate goal. Is because, I mean, we can log things on our phones and stuff like that, but we can't log things really easily from our power, or from power meters, or from our lawns, our lawn watering systems. So that's the ultimate goal of the Internet of Things, is just get everything talking to each other. But because it's logging all this data all the time, there's just streams and streams of data coming from millions and billions of devices worldwide. If we're all going to be gathering all that data, it's going to take a lot of storage. So we're going to have to be smarter about what sort of data we think is relevant. Do we collect this data and keep a log of it for every 10 milliseconds, or do we do it every minute? And so those are decisions that we're going to have to make on a case-by-case basis to determine how accurate do we need the logs and the records of all of these things that are connected to the internet or connected to each other, how much of it we actually need to store. And so it's just going to create a bunch of data. And I got this. Ooh. Sorry, this was going to a tech executives, and so I figured I needed to make it really flashy. So yeah, we've got all these streams of information coming. We have to store it somewhere, and that's going to create a massive data problem. I mean, we've already got these huge data centers right now, but depending on the type of data and how much information we need to store, it's going to need to be filtered somehow. And whether that's logging less data, or logging a lot of data and then processing it after the fact to only include relevant information that you want. That's going to be decisions that we have to make now that we're going to be storing more and more and more information from all these sensors. So why are we going to try and do this? I mean, people are already logging all this stuff, but it's not in like mass consumers' hands right now to try and interconnect all these things. It's like I had interconnected when I was at home. I could talk to Siri and tell her to change my Nest thermostat, but that was a gigantic hack. First I had to hack into Siri, then I had to hack into my Nest thermostat because they don't have an API. And so common people can't do this yet. So why would we want to help people do this? Why would we not want to help people do this? The first thing, in my opinion, is quality of life. So if we've got all these things, like I wear a fitness sensor on my arm. It's a Fitbit. And I can look and I can tap it and I can see what my fitness level is like today and how close I am to getting to my goal. This quality of life. Like I know that I want, in order to feel good, I need to hit certain goals every day. And one of those goals is how active I am. It's like when I work from home, I feel like crap at the end of the day because all I did was sit in my chair. And so that's why I actually come into work very often. I can work from home like 4 days the last year because I enjoy the walk here and it gets me exercise and it helps me hit my fitness goals. But without this, I really wouldn't know, well, why am I feeling like crap at the end of the day? And then it might take a few minutes to process, it's because I didn't walk anywhere today. I didn't do anything other than sit in my chair. So the technology here is helping improve my quality of life because I'm an active participant in my health instead of just having it happen to me. So we can make predictive algorithms. What's really cool is like once we can interconnect all these devices and make them talk to each other, we can actually kind of predict what's going on. Instead of just saying, if it's raining, don't turn on the sprinkler system. We can do things like, if it's forecasted to rain today, don't turn on the sprinkler system. Because right now, the sprinkler system only knows if it's raining or not. But if we interconnect the sprinkler system with the weather forecast APIs, then we'll be able to be smarter about the water that we use and conserve more water. So here's a couple examples I came up with predictive algorithms. So if it's summer and the weather prediction is less than 75 degrees, turn off the thermostat. And that way you know that, it knows what time of year it is. It knows what the prediction is for the weather. We don't need the AC on if it's going to be less than 75 degrees. And these are just examples of what we're going to be able to do once we can have all these systems interconnected. So if the power usage in the last 7 days is greater than 20 kilowatts, allocate an extra $10 from your next paycheck. And so this is a little scary. What if your power meter could talk to your bank account? Right? It's cool. Like somebody like me, I would probably set something like this up. But does the general public want something like this to be able to be done with their bank account? Like, what if someone hacked into their power meter? They could make people's checks bounce. So, anyways, that's a downside to being able to do all this stuff. So here's another if X do Y. So if it's daylight and the rainfall today is greater than 0.5 inches, delay irrigation by 24 hours. If it's before 10 a.m. and the predicted rainfall today is greater than 0.5 inches, delay irrigation. So it's like we can do all these smart things if people will actually take the time to set these things up and interconnect these devices. So not only can we do predictive algorithms, we can also have like event triggers, which is like when this event happens, do this. So I already have this one set up through ifthisthenThat.com or IFTT.com, one of those things. So when I'm tagged in a Facebook photo, it automatically saves to my Dropbox and it throws it on my computer. And so I get a little notification on my computer that, hey, somebody uploaded a picture of you to Facebook. Here it is on your computer, and it saved it for me. Because I don't know if people are going to, if they're going to delete that photo later or not. So I've actually got a copy of it for myself. So that's something neat we can do. When the last person leaves the house, and the oven is on, and the oven is empty, turn off the oven. Right? So it's cool that we could be able to do this, but think about all the implications of what these interconnected devices are going to have to know about each other. So we're going to have to know how many people are in the house at any given time. Right? Because we have a family of 4 people. If one person goes out the door, we don't want it to think that the house is empty. Right? So we're going to have motion sensors all over the place. Right? We're going to be collecting data. if the oven is on, right? The oven is going to have an internet connection, or at least a network connection to your to the rest of your house. Currently, I don't know that there are any ovens on the market that do that. People have never really seen a need to do that. However, I have seen a microwave with a barcode scanner on it that the guy hacked up, that when you scan the barcode of the packaged like frozen dinner, goes out to the internet, checks to see the cooking directions, and automatically programs the timer. So all he does is scan it, put it in the microwave, and close the door, and it automatically cooks for him. So he doesn't have to press 4 buttons. Quality of life. Making us lazier, and then using health statistics to make us more active. So what does leaving the house look like? Does that mean that the garage door is opened and then closed? Or does it mean that the garage door is opened, something leaves, and is closed? I mean, there's all sorts of edge cases. We're going to have to figure out what that actually means in order to do something like this. And it's people like us here at Skookum, and if you guys are engineers or technology companies that are going to have to figure these hard problems out, it's like, how do we determine these things? So let's talk about a little bit of the implications of this. I know I've been saying things here and there about interconnected devices and stuff like that, but this is the big one that people don't like. It's constant monitoring. It's like if I've got motion sensors set up in my house and they're going to store somewhere in the cloud, who's to say that Amazon or Google or whatever isn't giving that data to the NSA? I mean, I don't know why they would want to know if I was in my house right now, but I can see where they might want to if you're a high-profile individual. So the constant monitoring kind of gives that whole like futuristic, like Big Brother, these devices know what you're doing and where you are and who you are and why you're somewhere. It just it's like this dystopian future kind of makes me uneasy a little bit, having a constant monitoring like that. I mean, even traffic cameras make me uneasy. Like, I don't run red lights, but just knowing that they're there and they can take a picture of me, don't like it. It's going to require massive amounts of computing power. Not only storage, but if we're going to be post-processing all this data, we're going to have all this computing power to actually process it and make decisions based on it. And those decisions aren't just like, do I turn off the oven or not? It's like it could be gigantic business decisions and I mean, we're already using large data sets to make business decisions based on trends and things like that. But now that we're going to be having more and more things connected to the internet, we're going to have more and more data that we're going to be able to use to make those decisions. And whether those help or hinder us is yet to be determined. So there's data privacy. Are you going to run a server in your house that collects all the data? Will you be even allowed to with certain devices? Like, I know my Nest, I can't configure a server that my Nest can talk to at home. It has to go to Nest servers, and they store what temperature my house wants to be at. They store the schedule that I want my thing to be at, and they also provide the predictive algorithm as to if they should turn on my air conditioning or my heat. So data privacy is a really big thing. And then reliance in everyday life. So once this comes about, it's kind of like a government program. It's a lot easy. Once you get it started, it's really difficult to undo it. Like there's never been a government program that's ever been canceled. It's like once we get these devices, when we're logging all this data and we're using it, it's going to be very, very difficult to actually not use it anymore. Unless like society just like crumbles, which is also a possibility. And then there's artificial intelligence. So artificial intelligence is really hard, and scientists have been working on this since the dawn of the computing age. But really, it's just a bunch of if this then that we're using right now. We've never actually made any true artificial intelligence. We've got predictive algorithms, we've got learning algorithms, we've got Bayesian filters, but we don't have anything that's a true sentient being that can actually like make decisions autonomous of what its direct input has been. So, but I mean, yeah, that opens up to a lot of things like what happens if I have a sentient home? It can make decisions, and it sees that it's raining out, and it decides that it knows you don't like the rain, right? I'm not letting you out of the house. I'm locking the doors and I'm disabling the garage door opener. So I mean that's a huge implication of collecting all this data in the future. So there's also some hurdles here. I mean, we're talking about what the implications are, what it all means, but there are devices that do this currently. They just collect all this data and they log it, and you can look at it and you can analyze it. But there's a lot of hurdles to actually getting all of our devices interconnected and talking to each other. The biggest hurdle right now is device adoption by consumers. I have a Nest thermostat at home. I love it. It's a little pricey. People would rather go to Home Depot and buy a Honeywell programmable thermostat for $30 than buy a $250 Nest thermostat. But what they don't realize is that they're never going to program that thermostat. They're just going to use it to press up and down. So they might as well just buy the $5 one that they can just press up and down. But they like the idea of having the programmable thermostat, but the technology is too expensive at this point to make it so that it's a user-friendly device. We talked about this before. Artificial intelligence is insanely difficult, and in order to start making decisions for us, we have to. There are a lot of implications, like the Turing test and things like that, that we're going to have to implement. But getting something to the point where we can actually have the machines make decisions for us is a hurdle, and I don't know that it's one that I want to overcome, but it is a hurdle. Who programs all the triggers? So if we don't have artificial intelligence, we're going to need gigantic armies of programmers to actually determine how these devices interact with each other, with the world, and with us. And what happens if everybody knows that programmers don't write perfect code. What happens if there's a bug in my insulin meter, my automatic insulin pump, that there's an edge case, it detects something in my blood that it didn't know about? I don't know what that would be. But but then it freaks out and it said, I don't know what's going on here. I'm just going to shut off. And then you don't get insulin. We need fail-safes in place like that. So like an insulin pump should never always give you insulin. It should always turn off as a fail-safe. And so it's like a fire door. We need to make sure that the doors always close when there's a fire. So we're going to have to come up with those sort of triggers. And we're going to have to come up with all of the programs that run these devices and sensors. So processing data takes time. That goes into the massive amounts of computing power that we're going to have. And then the biggest hurdle of all is us. People don't like to change. So they think, well, I've got this old thermostat. Why do I need to buy this $250 thermostat? They don't see the benefit of interconnecting these devices. And until we make that benefit more aware to people and make it so that they want to have these devices interconnected, it's not going to happen in the mass consumer market. So let's talk about what we currently have that I would consider Internet of Things and how you can actually buy them right now. I've been talking a lot about my Nest Learning thermostat because I love it. It's awesome. If you don't have one, you should buy one. And I don't own stock in the company, I promise. So it knows when you come home. It's got motion sensors in it. It turns off the screen, and then when you walk up to it and you get like a foot from it, it turns on. And you can see what the temperature is, and you don't even have to like reach out to it. It just turns on. It knows you're there. It has humidity sensors, so it can detect if you've like I leave my door open, my sliding glass door open sometimes, and it's been raining recently, and so the humidity has been up in my apartment, and so it turns on the fan and not the AC or heat, just to get the humidity out of my house. So it knows about how to do all that sort of stuff, and it's a really cool device. So there's a Lockatron. I don't know if you've heard of this. This was a Kickstarter project where essentially you can adhere this to your deadbolt, your currently existing deadbolt, and it doesn't interfere with the interaction of the deadbolt at all. You can still use your key from the outside. You can still turn the deadbolt back and forth, but it acts as a an internet-connected unlocking mechanism. It's got Bluetooth on it, so that when you walk up to it, if you're paired to the device and it knows that you're walking up to it and it's locked, it'll unlock for you automatically when you get in within like 3 feet of the door. You can, they've got mobile apps where you can just open the phone, the app on your phone, and tell the door to unlock. It hits their server, and then their server pings the device itself on your home network, and it unlocks. But what's really cool about this is I think there's going to be a big market for this in the like vacation rentals industry. It's like I went to Asheville a couple months ago, and they had a little keypad entry on the door. And so the day before I got there, I was like, how do I get in the house? And they're like, oh, just use the last 4 digits of your phone number as the keypad entry. But somebody had to go there, and they had to enter the digits into the keypad so that I would know what to press. And every time they have a new guest, they have to change that. And so someone has to physically be there. That's just more work. But with Lockatron, you can actually allow guests access for a specified period of time to your door. And so the vacation rental owner could just put your email address into their system and say you get access on Friday at 4 o'clock and you don't get access after Sunday at 6 o'clock or whatever. And they send you an invite, you open their app, and then you have access to that door to lock it and unlock it for that specified amount of time. So that's really cool. I think it's going to be a big product. And then there's the health monitoring, FuelBand and Fitbit. Quite a few of us have these here. And they're just really cool for just logging data and understanding how you how you move all day long. You can trick them. So let's talk about the future today for us nerds, people that like to tinker and people that like to create things and actually implement this sort of stuff. The go-to, almost everybody knows about the Arduino. It was the very first commercially available, affordable microprocessor that you could learn how to actually create things and talk to sensors. And essentially, it's a rapid prototyping device. It's got a microprocessor on it. You can program it with a C-like language. And you can attach sensors to it. And then a whole industry has erupted around this with what are called shields, where it's the same exact shape of it, and it just sits on top of it, and it just adds functionality to the device. And you can just stack shield on top of shield on top of shield, which is really cool. So like if I wanted to add a Bluetooth shield, I've got a couple of those in my office, to make it talk wirelessly to a phone or to another Bluetooth device. You could do that. And then on top of that, you could add another shield that could then give you a breadboard that you could work with all of the pins and things like that. And so this has been great in the past few years to help people start to create these sort of things. But if you want something a little more powerful, you can get a Raspberry Pi. Raspberry Pis are actually, they're like $40, somewhere in that range. And it's a little mini Linux computer. It takes a little SD card that you can put in there. It boots up Linux, and it's got, I don't know if you can read that or not, but it says GPIO headers. And so it's got sort of the same input-output style pins that you can connect sensors to and make them interact with the real world. It's got a very slow processor, but when you're just logging data and making decisions, you don't need a very fast processor. It's when you're processing the data is when you need the fast processor. But it's got a network connection, it's got USB, it's got video out, it's got audio out. So it's really just like a mini computer. And it was originally created so that people could have learn about electronics and programming for a very, very low cost. Then there's this, my coworker Mark told me about this, the electric imp. It's essentially just like an Arduino, but it's got a Wi-Fi connection and it's got a web API where you can tell it to do things. Like you can say, increase the voltage on pin 4 through their web interface, and you could program all that sort of stuff through the electric imp so that it's basically like a pre-programmed network-enabled Arduino. And it's pretty cool. And Mark, did you make any progress with that project? Yeah. Yeah. Yeah, so he hooked it up to a solenoid valve to be able to open and close based on HTTP call that you can make from anywhere, basically. It'd make an iPhone app that calls the Electric Imp API and then it talks to it. Sort of like the whole Lockatron thing where your device... Lockatron uses Electric Imp. I did not know that. Thank you, Andrew. So, and this is a relatively new player. Some people have claimed that it's better than the Raspberry Pi. I haven't actually used a BeagleBoard before, but it's basically like people have told me it's a souped-up Raspberry Pi. It's got more headers on it. It's got smaller components. It's a little smaller. It's got micro HDMI and USD instead of SD cards and regular HDMI. So it's just a more compact version of that. So at Skookum, we're actually doing a lot of really cool stuff in this space. I've had the pleasure of working on a couple of these projects where right now we're building a device that talks to a server when you scan a barcode, and it makes decisions based on what to display on a an e-paper display on the same device. So it's a barcode reader, a Raspberry Pi, and an e-ink display. And when you scan a barcode, it goes out to a server and makes a decision about whether the barcode's valid and things like that, and then displays information to someone on the other end. We're working with a system. I think Josh might be able to explain this better. I wasn't on this project, but essentially sensors that correct me if I'm wrong. Sensors that control the environment in NASA clean rooms. So that's really cool. And then another one that I worked on is basically it's for this company called JRI where they make high-performance shocks. And so we built the iPhone app that talks over Bluetooth to these shocks that allow you to adjust the compression and rebound in real time, even while you're moving. And so traditionally these shocks, you can see on the bottom there, there's like a little thing that you could put a tool in and click it back and forth to change the suspension properties. They built a version that had an electric motor on it that you could send when they had a big in-car dash panel that had up and down buttons for it. But we were able to take that and add Bluetooth to it and make that talk to each other. So the next talk to a phone. And so the next step in that process, I think, is going to be starting to log the data back to your phone so you can see performance graphs and things like that. So that's another really cool project that we just actually wrapped up last month, I believe, for them. And they presented it to the press to much fanfare. Everybody seemed to really like it. So hope they do well with it. But that concludes my talk. If you've got any questions or would like to chat about anything in the presentation, I'd love to hear your thoughts. Yeah, Steve?
So you mentioned the Nest thermostat, and also getting back to the if this then that deal. Say I look at my thermostat and it says 68 or something like that, and I have a list of 100 rules. How do we solve this issue of what is going on? Why is this 68 degrees? Like how do I feel in control of the situation instead of feeling like all these rules are out of my control after I have so many of them?
Yeah, and that basically was asking how do we make people feel more in control of the rules that govern how these devices are working? And I think that's going to be a big it's going to be a big marketing hurdle for us to overcome as programmers to get the general public to adopt these sort of technologies. I know with my Nest thermostat, like I've got a schedule that I can look at online and know why it's on or off. But once we get more complicated things, it's like if it's cloudy out, don't turn on my AC. Like we're gonna have, it's gonna be a big marketing initiative to get people to understand that they can control these things, and then it's also going to be a business decision to determine how much of it we hide from the consumer, because as programmers we hide a lot of things from people that like backdoors and things that we can do in programs that the general consumer doesn't even know about, and so it's going to be a business decision that determines that as well. So I hope that answered your question. Yeah. Anybody else? Yeah.
Do you happen to know what protocols are kind of in the running for this device-to-device communication or control communication?
Yeah.
And what the consumer which you think is going to be the winning?
Right. So the question was about protocols and how these devices are going to talk to each other. Currently, there's not a whole lot of peer-to-peer communication going on. It's mostly client-server communication. And so these devices are talking to a server that is the authoritative answer to everything. And so I can use my device to tell my thermostat, but there's a server intermediary there. So my exactly. And so what I really like about If This Then That is that they're actually interconnecting all those different APIs. Because, I mean, some people use SOAP APIs, some people use REST APIs. Everything is different. And so there has to be either a standard that we decide upon or a clearinghouse that centralizes everything and can make them all communicate together for client-server interactions. But as far as peer-to-peer communications go, I don't know that anybody's really even bridged that gap yet of how my my electric meter is going to talk to my irrigation system. Yeah. Oh yeah, it is a huge hurdle. So, cool. Any other questions? Yeah, in the back.
First comment, apparently there are ovens that can tell you when like you're done cooking something and it's empty and you lift it on. I didn't get model specifics thanks to Twitter, but it does work.
Nice.
What I find interesting about like the lock system and the different ones is there is that database of how to decide which one to use and how to standardize it. We have a problem at our house because I have to call an ambulance on a semi-regular basis, and if the front door is locked and it's the middle of the night and I can't get up, or it's middle of the day and my roommate's not home, then how do I open the front door?
Yeah.
And so making it standardized would make it great because then the ambulance or the fire company can unlock my front door and come in and get me. But then I get really scared about, well, if it's standardized, what stops someone from the fire company or an ambulance or someone who hacks that?
Right. Well, it's like some stoplights have these systems that can detect whether an ambulance is a couple 1,000 feet away or something like that, and they automatically go through the cycle to let the ambulance through. And so it's like that. You can actually buy those on the black market. They cost like $1,000. And so you can just put it in your car. It's completely illegal to have. You can put it in your car, and you'll never have to stop at a stoplight again. But if someone catches you with that, it's just the same as like you burglarized a house. Like they will throw you in jail for having one of those devices. So yeah, it's a difficult thing to do where it's maybe we could come up with some sort of system where like only your local like ambulance company or fire department company has a physical device that they can get into all of the different houses. But then do you trust everyone that works at the company? So, yeah, that's another big problem to solve. I hadn't even thought about that. Yeah, thanks for the input. Go ahead.
Does IP6 fit into this at all? Because
Oh, is that what you're gonna say? Yeah, we're almost out of address space for internet connected devices directly connected to the internet. So yeah, IPv6 is going to be a huge thing because right now I forget the numbers and I don't even want to speculate because we only have a certain limited number of addresses that can be on the internet at any given time. There are ways of increasing that by using network address translation and things like that and putting people behind a bunch of people behind one single IP address. But yeah, IPv6 is going to be huge in making the leap towards having a lot more devices connected to the internet and being able to log things. So we had another.
That was going to be my question. Do you run IP6 in your home network?
In my home network? I don't know. It's whatever my Apple Time machine does. So I don't think so. Yeah. Yes.
My question was about artificial intelligence and kind of approaching it from that direction.
Yeah.
What kind of, I guess, advancements have they made since the beginning of the computer age, and kind of what are their goals ultimately? Maybe integrating with these.
I don't claim to be an expert on artificial intelligence, so I don't know that I can properly answer your question. But I know they haven't made a whole lot of strides towards having a sentient learning computer, other than what they're calling machine learning and like trainable algorithms and things like that. So, but yeah, I'm sorry, I don't know a whole lot about that other than we can't do it right now. So, what shouldn't we connect? Yeah, I think our nuclear power plants should be completely offline. But then you run the risk of like Stuxnet coming in through a USB key. So yeah, right. What shouldn't you connect? I think it's ultimately going to be up to the consumers how they want these devices to make their lives better and what devices they use. I don't use a garage door opener because I live in an apartment. So obviously I'm not going to need that to be a part of my daily workflow. So I really think it's going to be up to the individual consumer. And when companies start putting all of these things online and connecting them, it'll be very modular as to what people choose to connect to each other and to their lives. So, yeah.
So to kind of tie that together, you had the picture from 2001, you're actually talking about today. The way he managed to survive in the movie was there were physical components that the robot couldn't deal with.
Yeah.
And I remember talking to a guy who did intrusion testing, and they basically were able to hack into a dam and let basically the lake flow.
Mm-hmm.
In other words, you can do some pretty nasty things because everything, including the nuclear plants, is on the network.
Yeah.
So do you imagine a future in which, like I had a case where I turned on an old machine, hit Windows to clean it up, and suddenly deleted everything in Dropbox on all 5 of my devices. Because Windows saw this temporary hidden file, which Dropbox used, deleted it. Dropbox said, oh, those are deletable, and started deleting them across the whole network.
Wow. Yeah.
And I'm sitting there like, turn off Wi-Fi, unplug the wire. to get this old machine that I barely use to stop destroying the data on the cloud.
Yeah.
Right? Now, fortunately, Dropbox has dealt with this, and it's an easy fix, but imagine that it wasn't.
Right.
And so there's a small photovoltaic system that charges some batteries. There's a big red switch. There's no way to turn it on and off other than turning that dial with a physical hand or a lever or something. So your elevators, your AC systems that maybe turn gas on and off.
Mm-hmm. Yeah, and so while all these technological things are really, really cool, it's never going to remove the aspect of physical security. And so that's also something else I'm interested in. I'm in a lock picking group, and we meet and we talk about picking locks, and we pick locks and things like that. And we go to conferences and teach people how to pick locks so that people, because we're getting so fixated on all these technological advances that sometimes we forget that that the physical aspect of security. If I can pick the lock to your server room, I can get access to all of your things in the cloud. And so there's always going to be that aspect of physical security. And so as technology goes forward, so is physical security going to have to go forward.
But could you imagine, say, even an alternate network that's not even using standards, whereby your wallet device is talking to your lock, but it's not using TCP/IP, and it's not using some Wi-Fi standard. It's got something totally different, so that you get the functionality without the standard.
Yeah, so that's called security by obscurity, and that doesn't work very often. So, but yeah, I mean, the danger there is that someone is going to sniff that sort of traffic and figure out how it's talking to it, and they're going to break into it and either publish the protocol that you're using or something. But I believe in relying on established protocols to communicate and building in security, real security instead of obscure security. So, yes.
You remember the 80s, I fell down, I can't get up lady? They make those buttons that you can push.
Yeah.
And now they can tell if you've fallen over without you having to contact them at all. They call you and they're like, are you okay? Do we need to send a friend or the ambulance or whatever? I wonder, first off, it scares me. I probably need one, but it scares me. But the thing is that how do we warn customers of these technologies about all of that backdoor stuff without absolutely terrifying them that the developer next door can is there a way to explain that? Because I know I understand it, but a lot of people who use their phones don't even understand that this thing could fly to the moon and back twice. How do we explain that without scaring?
Yeah. And that goes along with the marketing and also consumer education. That's another big problem that we were going to have to solve. And when you said that, it reminded me of recently I saw this, I believe, Swedish company came out with these bicycle helmets. It's like it just wraps around your neck and it looks like a scarf, but it's got a crash detection system in it. So as soon as it's like an airbag for your head, and when it detects that you're like falling very quickly towards the ground, it blows up this thing and it covers your head. So it's a neat technology, but it could also be very dangerous if it detects that you're falling and you're not. So, but yeah, I think the consumer education piece is another difficult problem to solve. We have to figure out how to make people feel comfortable with using this technology, and I'm not comfortable with a lot of technologies that I use, but I do it anyways because it makes my life easier. Like Dropbox, there's been like known security issues with Dropbox, and they store your private keys on their servers. Well, at least they did. I don't know if they do anymore. But that makes me a little uneasy. But it's not going to stop me from using Dropbox because it makes my life so much easier. So we need to figure out how to strike a balance there between informing customers of what it does and informing them how it can make their life better. But I think people that are up on technology and are interested in this sort of stuff will never be completely comfortable with all this at all. So. Yes,
Real quick, my brother-in-law bought an Xbox One over Thanksgiving, and there's an option when you're setting it up to always be listening.
Yeah.
So even when it's off, it's sort of still listening for you to say like Xbox and this commands.
Right. Yeah. So you can turn it on by just saying Xbox on.
So you just, I mean, in terms of marketing and like mass consumers.
Yeah. But we have to take it on blind faith that Microsoft isn't listening to what we're saying when we're not using the Xbox. I saw a funny video the other day where a guy was recording his Xbox. He was playing like NBA Jam or something like that, and he was cursing, and he got a technical foul in the game because the Xbox One determined that he had said a curse word, and it gave the other team a free throw. So there's that sort of thing that's also, it's like kind of scary, and it's clever, but I don't necessarily want my Xbox telling me what I can and cannot say in my own home. So, yeah.
You mentioned about your Nest having a motion sensor in it, so when you come in and out. And this may not be a case scenario for you, but how does it handle pets? They tend to roam around a lot. Is it only looking at a certain height level? Yeah,
well, I mean, it's basically where the Nest is at on your wall. And so, I mean, unless you have like a really tall dog, I mean, it's the proximity. It's not even a motion sensor. It's a proximity sensor. And I think it works within like 2 feet or something like that. And so obviously if it detects motion in like far away, it's not going to be able to, well, it won't detect motion far away if it's on the floor, obviously, because if it's seeing out, it can only see out 2 feet. So, yeah. Anything else? Yeah.
You talked about like having taken on blind faith that Microsoft isn't just like listening to us when we talk in our room or whatever when the Xbox is off. We also kind of have to take it on blind faith that nobody's broken the security they put in place that we maybe can't see, right?
Yep.
Now, my Xbox can't kill me, I don't think. But some of these things, in certain weird edge cases, maybe they could, right? So
Carpal tunnel syndrome.
Right. Very dangerous, extremely dangerous. So you know, Microsoft is a big organization. What about some of these smaller companies? Maybe they hire subpar developers to put it together. You know, how do you deal with? I guess it goes back to that marketing adoption point, but like
and faith.
Yeah, faith. So much
Faith. Yeah, seriously, we put faith in organizations that we didn't even know about. Like when you sign up for an online service, you're probably also agreeing to Amazon's terms and conditions because they store everything on S3 or something like that. So it's like all these companies have layers of agreements with all these other companies, and so we don't even know about. So it's faith, really. That's all. That's all it is. So I think I think our time's up here. So thanks for having me. Appreciate it.